Hi, welcome to our channel. Today we will discuss about brake chips drilling types and techniques. 1. Improved tool life. 2. Better surface finish. 3. Enhanced chip removal efficiency. 4. Faster cutting speeds. 5. Reduced heat generation. 6. Optimized for hard-to-cut materials. 7. Enhanced process control. In CNC computer numerical control machining, chip brake drilling is a critical technique for ensuring efficient and effective operations, especially when drilling through materials that produce long, stringy chips. Here's a breakdown of the advantages of chip brake drilling. When chips are broken into smaller pieces, the tool experiences less stress from long, continuous chips that can lead to wear, abrasion, and increased temperature at the cutting edge. Prevents tool jamming. Smaller chips are less likely to build up around the tool, which can cause jamming, tool binding, or damage to both the tool and workpiece. 2. Better surface finish. Minimized surface damage. Small chips mean less pressure and force on the surface of the material, helping to achieve a better surface finish on the drilled hole. Reduction in chip recutting. When chips break more easily, the likelihood of them recutting into the surface is minimized, preventing unwanted marks or defects. 3. Enhanced chip removal efficiency. Preventing chip accumulation. Smaller, broken chips are easier to evacuate from the cutting area, reducing the risk of chip clogging or buildup in the tool path. Reduced risk of overheating. With more efficient chip removal, there is less chance of heat accumulation, which could otherwise affect both the tool and workpiece. 4. Faster cutting speeds. Higher feed rates. When chips are broken and cleared effectively, the cutting process can be run at higher feed rates, boosting the efficiency of the drilling operation. Improved cutting stability. By reducing the tendency for chips to interfere with the cutting action, the operation becomes more stable, allowing for smoother drilling. 5. Reduced heat generation. Lower cutting forces. With smaller chips, the forces acting on the tool are reduced, leading to lower cutting temperatures, which helps to prevent thermal damage to both the tool and material. Longer tool life. By keeping the tool cooler, the wear on the cutting edges is reduced, extending tool life. 6. Optimized for hard-to-cut materials. Increased control in tough materials. For materials like stainless steel, titanium, or composites, chip brake drilling can help manage the difficulties that come with producing long, stringy chips, improving overall drill performance. 7. Enhanced process control. Consistent hole quality. Chip brake drilling promotes stable and predictable cutting conditions, which contribute to uniform hole quality and dimensional accuracy over extended runs. Techniques for achieving chip brake in drilling. Using high-speed rotation and feed rates. Higher speeds combined with proper feed rates can cause chips to break more easily. Coolant or lubrication. Cooling agents can help in the chip breaking process by controlling heat and reducing friction. Chip control tools. Specialized drill bits with features like helical flutes can assist in breaking and evacuating chips more effectively. By leveraging chip brake drilling techniques, CNC operations can be made more efficient, leading to better tool life, higher productivity, and improved quality of the final product.